So the first person who's coming up is Eric Goldsmith from AOL. At last year's Velocity, he introduced a product called AOL Pagetest, and so it's great to have him back again. And he's also moderating a panel at 5:30 today, the last slot of the day, on something that everybody loves to hate, ads and slow performance. But today, he's going to give us a walkthrough on AOL Pagetest. Please welcome Eric.
Thank you, Steve. First, just a brief history of Pagetest. As Steve mentioned, we open sourced it last year. It was developed internally at AOL for the testing we do. We made it available via open source as a desktop plugin, an IE plugin. But then right before Velocity last year, we also released a hosted version of it. Well, what does it do? Well, as I mentioned, it's a plugin for IE 6 and above, and it performs timing of page downloads and visualization of that data. It also measures or compares against best practices and suggests what you can improve, what objects you can change. The hosted version has a few extra features. You can choose a test location and a test speed, so you can simulate different connection types. You can automatically do first run and repeat run testing, so you can check the impacts of caching. You can block objects so that you can see how your pages look without ads, for example. And there's a test history that can be viewed and shared with others. So lessons learned from my demo last year. I demoed the live hosted version in this room, and you can see a little bit of usage increase there during the day. I barely made it through that demo, all the load that was put on the site. So this year, just slides. There's the URL for it, webpagetest.org. It's a tabbed interface. I'm just going to walk through some of the interface here so you can see how to use it. First, you enter the URL you want to test, and then you can select the test location. And you can see there's multiple locations, a few. There's multiple connection speeds, connectivity types, and browser types. Shout out to the Aptimize folks. The New Zealand location there is hosted by those guys. You can select the number of runs you want to do, between 1 and 10. And the idea is that you can do more than just one, so you can see the impact of a few runs. You can decide whether you want to include first or repeat view. And you can decide if you want to make your test results public or private. You can also select whether you want to stop measuring at document complete, or if you want to wait until network acquiescence, until all the network activity has stopped. You can also override the default number of connections per domain for the different browsers. And also you can, if you want to measure timing up to a certain point of the page, up to the point where a particular DOM element becomes available, that's an option here too. So you can identify the DOM element by its ID or its attribute or what have you. There's some basic authentication that you can do here. There's also some basic scripting, more details there at that URL. Now this one's really cool. You can block objects from loading. So using essentially a text matching string there. If any objects containing any of that text is matched on, that object will not be called. So it's a great way to test your page without ads or without a widget or without something, so you can see how it performs with or without certain content. So then you submit the test. Everything's queued up and executed when available. Once you submit a test, you get a permanent URL shown there at the bottom as an example, and that is the URL for those results forever. So you can share that with people, and the results are kept forever. This is an example of what the results look like, the very first screen, some summary information and thumbnails that you can click on for more information. A lot of the data is graphical or tabular, but you can also access raw data from some links at the top of the page there. This is an example of the waterfall that we're all familiar with, the horizontal lines for each of the objects, color coding for the network components. There's also some vertical lines there. You see the green one that indicates render start or when something could be visible in the browser. There's another line that indicates when document complete occurred. Not shown in this example, there would be another vertical line if you defined a DOM element that you wanted to time to, so you could see, for example, when that DOM element appeared on the page. If you click on any of the objects on the page, you can get to the full details, the headers, and request and response headers. The data is available in a tabular format as well. And in addition to the traditional waterfall view, we have a connection view now that's new. So it essentially shows which objects were loaded over which sockets and to which domains. So you can get an idea of how effective the parallelization is happening there. This is a view of the compliance against our best practices. And then a detailed report showing here the objects that didn't pass and why they didn't pass, something that could be compressed more, something that didn't have the proper cache headers, etc. We also have a content breakdown. It shows how this particular example shows the MIME types by number of requests and by bytes, both in that pie chart form as well as a connection view. Same thing by breakdown by domain. Then the test history is searchable, so you can view your results, other people's results. You can search for URLs that have been tested. There's a forum for communication, talking about the discussions, bug reports, etc. Now, we also have, I mentioned a few locations to test from, but we'd like more. So if anybody's interested in hosting a test location, contact me. My email address is there. And if you want to host this privately, within your own firewall for your own QA testing or what have you, that's also available. More information at the URL there. Thank you.
I know when I'm analyzing a page, I want to see what's happening right now with my connection on my desktop. But I think the web-hosted version of Pagetest is also really valuable, especially for people who don't necessarily want to test on the browser that they're using or don't have the opportunity to install the plugins or tools that are needed. So I think that's really compelling. And I think it's cool. I talked about community a bit before and the connection between Aptimize and AOL Pagetest. It's cool that they're hosting that down under. So next up, so it's really cool when you have so much word of mouth, you don't have to do advertising. So I'm giving Simon a little bit of a hard time yesterday about not having a table in the exhibit hall. But he doesn't really need it because there were probably a half dozen talks yesterday where they showed HTTP Watch, which is the tool that his company does, Simtec. And this is Simon Perkins, the CEO and founder.
Okay, thank you for that introduction, Steve. I think I've seen 2 demos already of HTTP Watch. So I've got no slides, so I'm going to run a demo again for you. HTTP Watch is a commercial HTTP sniffer for Internet Explorer and Firefox. There is a free version available as well that you can download from our website from httpwatch.com. If you install it, you get a plugin for Firefox, only on Windows though, I'm afraid, a plugin on Internet Explorer, and a separate log file viewer. Now, I've downloaded and installed it here. This is Firefox 3.5, and I'll briefly show you again how to get the waterfall time charts. I just wanted to say, with the free version, it will show you basic information for any website, so you can see the waterfall type time charts. And it will show you more detailed information for any website in the Alexa Top 20. So if I open up the plugin window in Firefox, simply have to click on record. And then if I go to a web page, I'm going to go to the home page of our blog. That's got lots of images. It's not very optimized. It takes a while to download. So when I click on blog, I'm going to undock the HTTP Watch window, and it generates the familiar waterfall type time charts that you've probably seen in HTTP Watch and other tools as well. Now, I haven't got time to talk about the coloring of the time charts or how to read them in detail. If you're interested in that, have a look at the video from this session last year where I did do that. I just wanted to make this session just a little bit different from last year. So I'm going to just show 2 main parts of the user interface. The first is if you click on an entry in the list, that shows you detailed information for that request, that component of the page. And by going to the lower half of HTTP Watch, you can see low-level information like the low-level streams that were used to download that resource. You can see any cookies or headers that were involved. And on the time chart tab, you get a zoomed-in view of that segment of the waterfall time chart. Clicking on a colored segment, it tells you what that timing is. So I'm just going to show you the one here. That red segment is the wait time. That's the time interval that the browser had to wait for a response from the server after uploading the HTTP request message. If you click on the title of a page in the log, then we display some summary information across all the requests that made up the page. And so we display some performance data here. For example, a number of network round trips, any saving from HTTP compression, how many DNS lookups were performed, and how many TCP connects were required. Now, a common question we get from our customers is, well, this is great, we can drive this manually, but how about if we want to integrate this with our automated tests? We might already have some automation, but we want to run this in parallel at the same time, and then we can go and look at this low-level performance data alongside our automated tests. Well, there is a programmatic API to HTTP Watch. You can drive it really from any language that runs on Windows, so languages like C# or Ruby or Perl. I've got Visual Studio here, and I just wanted to show you quickly how easy it is to drive HTTP Watch. And you can really do anything you can do through the user interface and pull out any data item that you see within HTTP Watch. So I've got about 12 lines of C#. This is a simple empty cache test. And I'm going to start to single step through this, and I'll just talk about the important statements within this file. So the first thing it does is it creates a new instance of the plugin within IE, so IE.new. If I execute that line of code, you'll see a fresh instance of IE fired up. It's sitting down there in the taskbar. It's an empty page test, so the next statement clears the cache. It then starts recording, and that's just like clicking on the record button within the user interface. And then the next statement instructs the browser to go to a certain URL. So it's going to our download page. And the next statement waits for that page to be downloaded. If we go and spy on the browser window, we can see that it's completed the download. And when we go back into the code here, this next statement pulls out the first page. You can access the list of pages that were recorded. So I'm pulling out the page object for the first page. I can access a summary object on that page, and I'm pulling out 4 basic data items and just displaying those to the console. So if I switch over to the console here, you can see I'm outputting the page load time, the amount of data downloaded, the savings through the use of compression, and the number of round trips. Okay, and I'm just about up there for time. If I wanted to run that with Firefox, it's just 1 line of code to change, and I can run it in Firefox. It's exactly the same syntax. Okay, thank you.
All right, running live code in the 5-minute demo. Very, very brave, yeah. So next up is Stoyan Stefanov from Yahoo. He's going to show YSlow. YSlow 2.0 came out about a month or so ago, so I think he's going to highlight some of the new features. I just want to give a shout out to Stoyan. He's one of those guys who loves working on performance and making things faster and combines that with a passion to give back to the development community. So I know I get emails from him late at night. He's up late at night most nights, working on something like Smush It or something else that is going to try to make the life of developers easier and web pages faster. So please help me welcome Stoyan.
Thanks very much. I'm Stoyan. I was the architect for YSlow 2.0. Most of you are familiar with the tool. It's an extension to Firefox that basically looks at your page and tries to answer the question, why is it slow? It has been pretty successful, well over 1.2 million downloads at this point. And the new version was released a couple of months ago. So here I ran the tool on my favorite page, of course. So YSlow looks at, crawls the DOM and then hooks into Bnet Panel to figure out any additional requests that are not part of the DOM, like AJAX requests and so on. So then it figures out like all the components that it can find, right? So it gives you headers, some information about that. So then it loops through those components and checks them against a list of high-performance best practices, or rules as we call them. So in YSlow 2, we have actually added, I think, 9 more rules, like now up to 22. It's a kind of an overwhelming list now, so it's you can filter by category. And so after YSlow has helped identify some of the problems comes the solution, right, phase, which every developer's favorite part, solving problems. So Wislow gives you some quick advice here, also gives you a link for more information, and we'll also point out the kind of the offending components. And it will also try to automatically solve some of those problems. Like, for example, it integrates now with Smushed, so you can send all your images to the image optimizer and then get a download, a zip download of all the images and just paste over your files. So what I wanted to talk about actually was more about customization and extending Wislow, because this was my probably one of my main motivators when designing Wislow 2. It's basically it's a complete rewrite of the code base, and the idea was to be able to provide nice, clean APIs for future extension. So first, what if you think some of those rules don't apply to you? Like, for example, I have a personal blog, I cannot really afford CDN, so should I be just able to remove that? And the thing is, Wislow now has those called rule sets. So basically, you can create your own rule set. You can base it off of an existing one. Or start fresh, right? And then create okay, this is important to me, and so on, and create a new rule set. And then it shows up in the drop-down of all the rule sets, like it's something custom that is specific to you, and then you can run this. So there's more ways to tweak that. Once you have defined the rules that you're interested in. So for example, you can say things like, okay, how many points should be subtracted from my score if I just forget to gzip a single file? Should it be 10 points, 20 points, up to you? And then what's the relative importance? Which one of those is more important for me, and so on. So this is not in the UI, not to add clutter to it, but it's available if you go to about config, right? And search for Wislow. So this is the custom rules that I just created, and it's a JavaScript JSON object basically that contains all the configuration you can play with. And the other thing is extensions. So it's not in this version yet, but in the upcoming releases, now that you have created your own rule set and tweaked and so on, it would be nice to be able to share it like with the rest of the team, so you're on the same page, or the rest of the world. And in the next version, you'll be able to just export this and create basically Wislow will generate a new Firefox extension for you to just give out. And if you want to create your own custom rules, let's say you've done the research, you've come up with some ideas, and you want to codify this into your Wislow checks. So to do that, actually, the API is pretty simple. You do is wislow.addRule and pass a JavaScript object, which basically has the name of the rule, the URL for more information, and a length function. And Wislow will call your length function, pass all the components as a parameter. Then you just loop through those components, make your checks, and return a result object. So it really can be done in just a few lines. And hopefully, we as a performance community, at some point, we'll have a nice little pool of rules, some that come by default from Wislow, some that are contributed by different extensions, and you can pick and choose and customize each one of those, and because at the end, it's about the speed of your page. So thanks very much.
All right, so we're about 5 minutes ahead of schedule. So at the end, we'll do 5 minutes of Q&A. I'll ask all the demoers to come up. So start thinking about questions that you want to ask about any of these tools, future features, things like that. Jim Pierson is up next. He's going to talk about a tool called VRTA from Microsoft. And you know, it's really important to optimize JavaScript and CSS, but I think we all know and experience that the impact of network latency on our pages is really important and is probably the dominant factor in speed up. Marissa talked about chunked encoding. Small images are $1, big images are $1.01. And we saw some of the browser developers talking yesterday about the optimizations they've done in networking, increasing the number of connections and other best practices like domain sharding. So VRTA is a tool, I've used it a few times, that gives you a lot more visibility into what's happening on the network. So Jim's going to give us a look at VRTA.
All right, thanks, Steve. So I've been at Microsoft for about 14 years and started in MSN and Windows Live, and then recently moved to Office. But as a performance engineer, I've really struggled with what I call the rich look and feel, or trying to download 9 shades of blue as quickly as Google does, for example. Okay, so we've had to build a number of tools to allow us to look at how do you download all that stuff so quickly? How do you make the page much faster? VRTA, Visual Round Trip Analyzer, is one of many tools in a suite. As I saw in some of the other tools here, downloading the page repetitively is a piece. We actually separate that out into another tool we call WebRunner internally. But VRTA is the visualization part of that. We released it on downloadmicrosoft.com in October, and so I'll show you here a little bit more about it today. I am a Star Trek fan, and there is one movie, Wrath of Khan, that talks about a guy, very brilliant guy, that was frozen in the 20th century and floated in space for a couple hundred years and then showed up, had a battle with Kirk and Spock. And there's a scene where Spock notices that he flies his ship two-dimensionally, like it were an airplane, not a spaceship. And they end up winning the battle because of that difference. They were able to fly three-dimensionally. Okay, so my suggestion here is not to think 20th century or two-dimensional, as I show you. I will say the waterfall is two-dimensional. Okay, it's limiting us in how we look at page loads. Okay, it doesn't tell us about the TCP connection. It doesn't tell us how TCP is ramping up over time, and so you can lose that fact and not know that you're wasting connections. Okay, so VRTA is multidimensional in the sense that you have TCP ports that you open up, and then you can see files loading on each of those TCP ports. We also then colorize the files based upon the type of file. So red is HTML, gold, style sheet, tan, JavaScripts, and blues are images. Okay. This is the VRTA 2 version from a couple years ago. Recently, we added more context, another dimension inside of each file. You can see the pink line where the TCP connection is done. Then the time to first byte when the server downloads is the gray line. And then you see the staircase ramping up. These are packets downloading as part of the file. Okay. So VRTA basically looks like this. And it is browser independent, so it sits on top of Netmon. When you start VRTA, you basically are starting Netmon. Then you go and you download your web page, whether it's through an automated tool or manual. Then you stop the tool, and it does this analysis for you. I did want to mention that you don't have to use Netmon. You could use other things like Wireshark that have a Netmon-like output. Okay. You can hover over individual files and then see what's inside of it. So here you're seeing there's a header that allows you to see how many bytes were sent up and received. Okay. What is the GET request, what's inside it, what are the headers, what are the responses, and then down below are the packets going back and forth. So I can very quickly click on one of the icons and drill down into the packets and see, I can say in the left-hand column, frame number 258, I can go into the Netmon trace and see what's inside of that. Okay. You can save the files, as I mentioned. I want to show you a couple actual best practices using the tool, not just the tool itself. So here I'm looking at a website that's loading across 2 ports. Remember, most of the older browsers only open 2 ports per domain. They can have many ports in parallel. But you can see the very slow time to first byte on the red guy there. Then there's style sheets. Notice the tan images, the tan blocks. Those are JavaScripts that are downloading. Okay? And notice that they're alternating. That's because JavaScript was blocking in most of the older browsers. Here's a new feature that we're putting in VRTA. you see the actual packets loading. People talk about slow start, ramping up, okay? Here you see packets going out to the server, an ACK coming back, a pause, and then the actual data coming back from the server. ACK from the client, more data, ACK from the client, more data, okay? Here we have small image files. They load very slow. You're spending most of your time on the network. Large files, super fast on the network, okay, because the TCP can ramp up. And I think I'm out of time, but just some examples. Okay, we do have an all-file summary that shows individual files and statistics on those. What we've added recently is a set of rules, and I like Steve's list of rules that the different tools had or didn't have. I think we're going to be adding a bunch that were missing. Okay, this set of rules can be automated so that you can run against a whole bunch of pages and then see what are the different problems. Okay, and mention things that we didn't have there. Okay, and download this from downloadmicrosoft.com. Thank you.
So the next speaker always confuses me because his name is Jan. Come on up, Hansa. But he goes by Hansa. And how I first started interacting with him was through a mailing list, and I thought he was two people. And so now I know that it's one, but he does the work of two, so it's still pretty close. So Hansa is a major contributor on the Firebug project, which we all know and love. And he's the one responsible for the major upgrade of Firebug's Bnet Panel. And so he's going to be giving us a walkthrough of some Firebug features. And the Firebug working group is a very active open source project. So I encourage anyone who wants to participate in that to come up afterwards and talk to Hansa about how to get more involved and contribute to Firebug. All right, let's welcome Hansa.
Yeah, thank you, Steve. So I'm going to talk about Firebug and how Firebug can be used for debugging web page load. So let me... Slow computer. So first of all, Firebug is an open source. It's made as a Firefox extension, and it's highly extensible. There's currently over 20 extensions available. And if you want to install Firebug, just go to getfirebug.com and download it. As soon as Firebug is installed, there should be a small icon on the status bar, on the Firefox status bar, and if you click it, the Firebug's UI should just pop out, and you should see exactly what you see on the big screen. So in this talk, I don't have much time to talk about every single feature, but I'm definitely going to focus on the Bnet Panel, which represents the network monitoring tool, makes possible to sniff for all the HTTP traffic which is executed by the page, and I'm going to give some examples how it looks like in the UI. So the Bnet Panel. So let me refresh the page. Yeah, so the content of the panel simply displays list of all requests that have been executed by the page. At the bottom you can see a row which displays some summaries. So in this case it's like 11 requests, total size, downloaded size, and total time. There is also a graphical timeline. I mean, it's a typical waterflow diagram which shows how all these requests flew over the wire in time. Every entry is actually expandable. Let me show you an example. So if I click the button, a request has been executed. I can expand the requests and see all the possible details which are often interesting for developers. So in this case, I can see all URL parameters, I can see all headers, posted data, and usually the most important thing, which is the response content. So another slide. Since there is a lot of formats that can be received from the server, Firebug is trying to provide an inspector the correct way how to display these data. So for example, if the server sends something like HTML, so let me show you an example again. So in this case, an HTML document has been received from the server. There is additional tab called HTML, which shows a preview of the response. In case of JSON, there is a whole JSON tree which exactly shows the structure of the JSON. So it's simple to inspect the response content. As I mentioned at the beginning, one of the cool things on Firebug is that it's highly extensible. So it's also possible to extend the net panel itself. In this case, the typical example is cookies. On my computer, I have installed another extension for Firebug that actually appends a new tab, new content inspector, and in this case, it displays cookies that have been received and sent over the wire. So next slide. One of the new features we have implemented in version 1.4 is export of all these collected data which are displayed in the net panel. So it's actually visible as an export button, very simple to use. Just let me refresh the page so there is something to export. So I can just click the button, click Save, and all the data should be exported. In this case, an online viewer is automatically opened, and you can see actually how this exported data looks like. We have been working on the format of these data with Simon Perkins from HTTP Watch, and the goal is to have more tools which are supporting the same format, so it's more easier to use all these exported data and analyze them for further purposes. So my last slide shows one of the newest features that, or actually one feature which is implemented in Firebug 1.5. At the present, it's an alpha version, is debugging of the network communication. So there is a little yellow pause button, and the feature is called Break on XHR. And if you want to use it, just click the pause button, and then the JavaScript debugger will automatically stop at the place when the request is actually originated. So if I click the button, you can see the script panel has been automatically activated, and the debugger is showing the line when the request has been executed, which is the request.send line. So that is pretty much all I wanted to show. As I said, there is much more to talk about, but it's not possible to do it in 5 minutes. And I'm definitely curious about any feedback, and I appreciate any ideas how Firebug could be used and what could be improved. And just out of curiosity, how many people here use Firebug or used just one at least? Oh, that's a lot, yeah. Thank you.